All right, section 10.3, Slope-Intercept Form. These are the topics that we're going to be covering. Find the slope of a line given 2 points. Find the slope of a horizontal and vertical line. Discuss vocabulary. We're going to graph linear equations by finding slope and y-intercept. Interpret slope as a rate of change, and then use slope-intercept form to write the equation of a line. Use the slope-intercept form to write the equation of a line given its slope and y-intercept. Yeah, so that's correct. So you'll probably see this quite a bit: rise over run. Rise goes up and down, run goes right. So normally when we're counting slope, if it's positive, we're going up and right. That's your rise over run. Slope definition is the measure of steepness, tells you how steep something is. So the larger the slope, the steeper the line is. Sometimes they call it the pitch of a roof, that's the steepness. Grade also. So here are just some images that kind of show you slope, rise over run. From a graph, this is a picture that shows you rise over run. You know, we go from one point and we go up and right to get to the next point. We might go down and right to go. So your rise might be a fall. Measuring how you do the slope. So if you go up, depending on what the axis is counting by, it will be different. So notice the y is counting by, looks like 30s, 30 intervals, and then the x-axis is counted by 2s. So each square may not be the same. So we went up 2 squares, which is 30 each, so that's a 60 difference. And then the x, they're actually counted by 1s, it's labeled every second one. So they're counted by 1s, go over 2 squares is actually 2. So your slope is 60, the rise, over 2, and it gives you a 30, slope of 30. So that's how we'll be finding slope. Okay, so you got several images and several pictures. This little polygraphic curve will have several different slopes between 2 points. You just find the slope between 2 points at a time. So here are some more examples showing you if you have a point, we'll use the slope formula, which we've gone over. Okay, so you have your y2, y1, x2, x1. You subtract the y's, subtract the x's, get the difference, and that'll tell you your slope. Here is that formula again. Slope is calculated y2 minus y1, which is your rise, is the y values, and then x2 minus x1, your x values. So you can just find the difference in the y's, difference in the x's, put that over each other, and that'll give you your slope. So here are some examples provided by Hawks. So either way, you can go up and right. This one still goes up and right, but it's shown in a different way, saying down and left. It's the same pattern, is going up and right. Okay. And what that means is if you have a negative divided by a negative, it's going to be a positive. And then right here, positive and positive, you still get the same number, 3 over 4, rise over run. And then over here, you get negative 3 over negative 4, you still get 3/4. Here's some more examples. So here we go. Positive slope, increase from left to right. We go up and then right. From left to right, we always count. Negative, they decrease, so they go down as you go from left to right. So that's one way to determine if the slope is negative or positive. Is it going up as you go left to right, or is it going down as you go left to right? So horizontal and vertical lines. So horizontal line is going to be y equals some number. Vertical line is going to be x equals some number. These are y equal and x equal because y will only cross the y-axis. Right here, here's the y line. It will only cross y. and it will stay on whatever that y value is. So you can see the y coordinate of 3, and y equals 3 is going to stay 3 the whole time. X will be changing, y will stay 3. What you will notice when you do the slope formula is that the two y values, the rise, will be the same. So when you subtract them, you get 0 on the top. And therefore your slope, 0 divided by any number, is 0. And if you have a slope of 0, that is your indicator that we have a horizontal line. So here we go. The slope of every horizontal line is 0. That's always going to be the case. If you have a slope of 0, you have a horizontal line, the equation is y equals a number. And whatever the y value is of those ordered pairs, that will be the equation, y equals that number. Now, we also talk about vertical lines. So same scenario, if you do the slope formula to find the slope of the two lines, you'll notice the x values are the same. And when you simplify, you'll get some number divided by 0, which in math, you always must remember we cannot divide by 0. So this is called undefined slope. It's not a slope. We can't say 5 divided by 0 is 0. It's not. It's undefined. So anytime you have undefined slope, you're going to have a vertical line, okay? As opposed to 0 slope gives you a horizontal. Vertical line is x equals. Notice this line going up and down vertically is crossing the x-axis only. So therefore x equals, and look at the x value, is 4 in both cases, so x will equal 4. So here's the key. Horizontal lines, the slope is 0. Vertical lines, the slope is undefined. Horizontal line, y equals a number. Vertical line, x equals a number. So here are some examples. Equation y equals 5, slope is 0. Just graph it. Goes through this point 0.25. That vertical line example. Now we have slope-intercept form of the line. Here it is in this pink box here. Y equals mx plus b. M is the slope. The b is the y-intercept. It says by letting x equal 0, right here, which we've done finding the intercepts. If you let x equals 0, this simplifies to y equals b. That same form of a horizontal line, which is giving you that intercept, the y-intercept. Okay, so whatever b is your y-intercept, and the m is your slope. So here they are, just explaining that a little bit more. This is called slope-intercept form. M is the slope, and then the ordered pair is 0 for x, and the b for y is the y-intercept. Here's standard form. B not equal to 0. Well, it can be, but this is kind of coming from, say, an example in 5. You'll get a y-intercept by not b if b is not 0. Okay, so a few more examples provided for you, and then we'll jump to Hawks and do our own. So just several examples of finding and writing slope.